Okay, sorry for the interruption. My phone ran on storage randomly, so yeah, continuing on. So as seen before, I have moved on a lot, and that's my bad, but anyways, this is the right remote sum, and the right remote sum graph will look like this. Since the table is increasing, and f of x is increasing, and f of x is also increasing, this is what the graph would probably look like. And a right remote sum meaning that the utmost right vertice of a rectangle would always hit the graph. And for a left remote sum, instead of, you still use the differences of the x's, so 5, 2, 2, 2, but instead of using the right term, use the left term, hence the name left remote sum. And this will be your answer for this particular graph or table. And the graph of it will look like this, in which the left endpoints of the rectangles would hit the graph. So for this case, a right remote sum would be an overestimation, as the right remote sums, these rectangles are over the graph, since the area between here is over the graph. But for a left remote sum, the area is between the graph and the remote sums, thus being an underestimation for a left remote sum in this case. A midpoint remote sum, let's say in this case you have they want you to do two intervals for a remote sum. So we do the two x's, so 7 minus 0, 7, 12 minus 7, which is 5. And then we use the mid value. In this case, it would be 8 and 20. 8 and 20. And a midpoint remote sum, which the rectangles would have the mid section of their rectangle. Oh, they're focusing. Okay. On the graph. So it'd be like right here. And now typically midpoint remote sums are balanced in a way, since they both have parts that are in and under, but they are also more typically I think the approximation is also more accurate, but I don't know. Okay, so for a trapezoid remote sums, they are considered the most accurate, which I will show you later. So the integral from 12 f of x dx. Oh wait, shoot. Sorry, Mr. Boudreaux, I couldn't get off my eraser. These are all approximations. Midpoint sums are, remote sums are always approximations, since we don't know for sure about what the actual area is. Let's say they want 4 intervals. So we do 0. So the formula for that is 1/2 times all of the intervals. Basically, so of the distance, which is the x's, times the two values together. So in this case, it would be, the first interval would be 5 from 5. So it's 5 minus 0, which is 5, times 8 plus 4 plus 2, difference between 7 and 5, over 8, times 8 plus 15, plus 3 times 20 plus 15, plus 2 times 20 plus 22. All of that times by 1/2. Now this generates the most accurate approximation so far. Now a trapezoidal remote sum in this case would look like this, in which the trapezoid would be like this. Since a trapezoid can adjust to the angle of the graph, it has a much more accurate display of what the accurate approximation of what the graph would look like. All right, so let's say that we have a question in which, for a integration, it says the rate at which water pumped into the container in gallons per minute is being represented by the twice differentiable function of f of x equals 7x plus 4x squared plus 2. 7x cubed, my bad. Which means that the rate at which water is being get in is represented by this function. The rate at which water is being drained out is represented by the function of g of x equals 17x squared plus 8x, which means that the water is being let go of the container which is represented by g of x at time t equals 0. There is 500 gallons of water, which is really crucial into finding how much water there is in total. The water is being pumped and drained from the container at the times of t equals 7 to t equals 12. So let's say the part A, or number 1, the question is asking, find the amount of water in the container at t equals 8 minutes. So in order to find that, we try to find the amount of water that's already poured into the graph with the coexisting water. So let's say that h of x, the amount of water in the container at t equals 8 minutes, equals to h of x as 0 plus integration from water being pumped and drained from the times t equals 7. Okay, let's say this is t equals 0. I think that one works much more. From 0 to 8 of f of x dx, which means that of h of 8 my bad, equals to 500 plus the integral from 0 to 8, which is, using our calculator, 0 to 8, 7x cubed plus 4x squared plus 2 dx, which is 7,866.667. Now this only represents the amount of water that was poured into the tank from the times 0 to 8. But the question says find the amount of water in the container at t equals 8 minutes. So we need to factor out the amount of water that's also drained from the container. So integration from 0 to 8 g of x dx equals to 0 to 8, 17x squared plus 8x dx, which equals to 3,157.333. So h of 8 equals to h of 0 plus integration from 0 to 8 f of x dx parentheses minus the amount of water that's poured out, so integration from 0 to 8 of g of x